path that extends in two opposite directions with no end and has infinitely many points. So a line is actually just a bunch of points as close as they can be together so that it doesn't look like there's any gap, okay? Basically, a line is all these points. If I can get my, of course not. My pen does not like this. Basically, if I just kept doing points, eventually what I get from it is a line. Okay. And with a line, there's going to be points on there, but usually they'll just point out a few of the points. So let's say we had point A and point B on our line. We would call this line AB. So you just take the A and the B and put them together, and then you put a line over top. So you're going to do the bar with an arrow on each side, and that is said line AB. Okay. Now, a lot of times people ask me the question, can I switch the letters? And for a line like this, you absolutely can. If I said line BA, it's the exact same line. Okay, so you could flip them around and it would be the same thing. Okay. Sometimes they're gonna just put a little like cursive letter next to it. So like that, they might call it line L then. You would just say line L. That's another way that you can name a line. But those are basically your options for how you're gonna name a given line. Okay. Questions on that? Okay. Planes are hard ones to draw. A plane is not visible. It has no thickness. It's just a flat surface that extends forever in every direction. So you can kind of think of it as like the floor, right? The ground just keeps going in every direction as far as you can see. The ground is a plane. Or you could take like the wall. That if that wall just kept going straight up, straight down, all the way to the left and the right as far as you could see, that kind of represents a plane. There is a plane there, okay? It has an infinite number of lines through it. Here is how we represent a plane. It's not a perfect representation, but it's the only way we can draw something that actually doesn't exist visibly. So we kind of do it just as like a parallelogram that represents a plane. And then within that plane, there's a few different ways you'll see the points or the lines or whatever that are in a plane. If there is a letter with no point or line attached to it, you can name a plane with just that letter. So I could call this right now plane P. Okay? But if there are points, you have to have 3 or more points to name a plane. So if we're working with points here, let's say I have point A and point B and point C, okay? I can call this right now plane ABC. Okay, now you can do more than that. You can do A, B, C, D, E, F, G, and that can be a plane, but it has to be at least 3 nonlinear points. So 3 points that don't lie in a straight line, okay? So we'll just put that here, at least 3 points. And then you just gotta make sure that they don't lie in a straight line, because if they're in a straight line, I could put a plane through a lot of different directions, right? If they're in line with each other. All right, so that's a plane. Collinear. What do you see in the word collinear? Line or linear, right? You see the word line in there. So that's what you need to think of when you think collinear points, that those are points that lie on the same line. So for instance, if I have a line here, we would say these 3 points are collinear, okay? Now, there is also non-collinear. Oh, that's not pretty. sorry, that says non-collinear. And that would be like a point here, a point here, and a point here. There's no way I can draw one line through those 3 points, okay? So that would be non-collinear. Collinear means they are on the same line. Same thing goes with coplanar, okay? If you're thinking of a plane, right, that's like our parallelogram setup. If there are lines that lie on the same plane or points that lie on the same plane, we call them coplanar. So if my plane looks like this, and I have X, Y, and Z, I would say those 3 points are coplanar. Now, the thing that can be a little bit tricky with coplanar versus non-coplanar is there are planes everywhere. So you might have a plane here, and I'm just going to draw a line through the plane. So the dotted line is just representing that it's kind of hidden behind the plane right now. If I had a point up here, point A, and a point here, which is point B, and a point down here, which is point C, and they say, are they coplanar? What's your answer? It's kind of a trick question. The answer is yes, okay? Here's the deal. Here's my plane, right? Here's my line that's cutting through it. I can find the 3 points on that line, and I can put a plane through those 3 points, right? If this is my line, 1, 2, 3, there's a plane that cuts through all 3 of those. So even though they're not on the plane that you see, they still can be coplanar, okay? You cannot have 3 points that are not coplanar. Any 3 points will always have a plane that goes through it. We cover that tomorrow. There's a theorem. It's one of my favorite theorems. So I'm not going to go into a lot of detail with that right now, but you will always need at least 4 points for something to be non-coplanar, okay? And like I said, I'll talk more about that tomorrow, but just so you're kind of chewing on that idea, we'll go with that. Questions so far? Okay. What I'm going to do is I'm going to draw for you a picture. You can try and draw it along with me. I'm just going to move it over here off of my notes a little bit because I did too much scribbling there. But for this first example, we're going to take this as our plane. And I'm going to draw a line through the plane. Do you understand what I'm saying with the dotted line? So it's kind of like if your plane is sitting like this, and I put a line through it, where the line cuts through initially, because my plane is kind of slanted, you wouldn't see the line for a little while, right? That's what the dotted part is, the line that you wouldn't see, but then it continues past that. Does that make sense? I'm drawing that. Okay, so here's one line. This is where it would cut through the plane. And then I'm going to draw another line on that plane. And then we're going to letter some of this. We're going to call this point R, point Q, and point S. And then this will be T, and this will be N. And then we're going to put a P here. Give you a sec to finish drawing that if you're drawing. Okay, so we're just going to talk through some of the things that we see with this, with coplanar, collinear, all of that type of thing. So the first thing I want to know is we have line QT. Okay, to name a line, you're always going to use 2 letters. Okay, so line QT right now is the one that's going more vertical. Can you tell me two other ways that you could name line QT? You could call it line TQ. Do you see another way that you could name that line? TN would work. Okay, or QN or NT. So there's a lot of options there, right? But there's multiple ways that you can name that line. Okay, how about we have plain P. Can you tell me two other ways? Oh, I didn't put my other point on. We're going to add a point. I forgot to add this point. So put point V on your plane somewhere. Can you tell me two other ways that you could name plane P? How many letters did we say you have to have? You have to have 3, but you don't want them in a straight line. So can you give me a name for that plane? RS, okay. RQS would be in a straight line, so it is a plane, but there's also other planes that cut through that same set of lines. So I would do like RVQ, so that you're not in the straight line. So RVQ would be one. Can you give me another one? RVS would work. Okay, so again, lots of ways you can name it. You could name it RQSV. You can do 4 letters, and then it doesn't matter that 3 of them are in a straight line because one of them is not. Okay. Okay, how about, can you give me 3 collinear points? Three collinear points in that whole picture. So collinear means they're where? On the same line, right? Yeah. TQN would work. So point T, point Q, point N. Okay, so that would be 3 collinear points. Can you tell me another set of 3 collinear points? Point R, point Q, and point S. Okay. How about, can you tell me 4 coplanar points? Yeah. R, Q, S, and V. So point R, point Q, point S, point V. Now, technically, there are other options. You could say T, Q, N, and any other letter on that plane, because you have the 3 in that line. All you have to do is make your plane connect to that other point. So you could say TQNR. You could say TQNS. If there is a plane you could put through it, they are coplanar, even if it's not the plane that's drawn in. Okay? Questions on that? Okay, let's go back to this stuff then, some more definition stuff. Space, when they talk about space, you're going to hear this a lot in geometry. Either it's in a plane or it's in space. In a plane means 2-dimensional. In space means 3-dimensional. Okay, so we're dealing with all the points in 3 dimensions. So depth, width, height, length, however you want to think of the wording of it. But 3 different dimensions, that's space, okay? A segment, we talked earlier about a line. A line keeps going forever. A line has no end. A segment is just a part of a line. So if I have a segment, it's going to look something like this. If this is point X and point Y, you'll have your end points. Okay, notice there's no arrows. It doesn't keep going. So that's a segment. And you name a segment different than you name a line because they are different things. So the way you're going to name this, very similar to a line, you're going to put the bar over top and you just don't put arrows on it. Okay, so that would be segment XY. What's the other way you could name that segment? yx. Okay, so you can do it either way. I would say most of the time in math, mathematicians tend to put things, God bless you, in alphabetical order. You don't have to put it in alphabetical order. It's not wrong if you flip it the other way, but I feel like most of the time, mathematicians go with the alphabet, which is funny because they like numbers, but letters apparently matter too. So, questions on a segment. Okay, so then array is kind of like taking a line and a segment and combining them. So array is a segment on one end, but a line on the other end. So basically you have an end point and then an arrow going one direction. So if this is A and B, we would call it ray AB. Now here's the trick with rays. You have to name it starting with the end point. So this you cannot call ray BA. There is no ray BA here. If I did this then, what would we have to name that ray? DC, okay? So your end point always comes first, which means my arrow is actually gonna point the opposite direction of what it looks like in my picture. But it's always, the arrow is always gonna point right when you name it, and then you always start with the end point, okay? Questions on that? Okay, last definition is opposite rays. If you take your rays and you point them in opposite directions, they have to share an endpoint. Okay, so my endpoint's gonna be in the middle here. We'll call this C. If I put a point A over here and a point B over here, they're gonna form a straight line, but they have to only share that endpoint. There can't be any other overlap. So we would call these two rays what? What's one ray? CA is one of the rays. What's the other one? CB. Okay, so they have to have that same endpoint. We would say ray CA and ray CB are opposite rays. Okay, questions on that? All right. Example 2, and then we're done. Okay, first thing I want to know are what are the segments that you see in this picture? How many segments are there in this picture? There's 3, right? What are the 3? Yeah, so DE, which you could also call ED, right? But you don't need to name it both ways. Pick one. Okay, so DE. What's another one? I heard someone say EF. And what's the last one? DF, right? So the whole thing is a segment. Yes, there's a point in between, but there's a million points in between, right? It's made up of just a bunch of points. Okay, so those are your segments. Can you name the rays that you see? What rays do you see? There's ray EF, ED, ray ED. See another one? DF. Okay, now here's the deal. DF is the same ray as what other ray? DF is the same as DE, right? Same endpoint. So DF is this. DE is that same red ray. So you don't need to call it DF and DE because that arrow keeps going forever. They are the same ray, okay? What's the other one that we haven't named yet? FE or FD, either one of those. And again, you don't have to do both, FE or FD. Okay, questions on that? Okay, my question is, are EF ray EF, and ray FE, are they opposite rays? Why not? They don't start with the same endpoint, and there's overlap, right? You have to have the same endpoint, and you cannot overlap. So this would be a big fat no on are those opposites. What are the opposites? EF and ED, okay? So EF, ray EF, and ray ED are opposite rays. Okay, any questions on that? Okay, I know that's a lot of mind-numbing